solve the equation. The square root of the quantity 8x minus 4 minus 1 equals x. Now, square roots have domain issues, which means we're going to have to check our answers for extraneous solutions. First off, we cannot square terms. For example, 2 plus 3 equals 5. If I were to square terms, now I have 4 plus 9 equals 25. That doesn't work. You don't get to square terms. You get to square sides. Also, like x plus 3 quantity squared is FOILed out. So we can't square terms. We have to do something else. So in order to simplify this square root, first off, I want to isolate it. So we have the square root of 8x minus 4 equaling x plus 1. Now that it's isolated, when I square sides, not terms, the radical simplifies. If I try to square before, the square doesn't immediately activate and get rid of the square root because the minus 1's in the way. And we can't square terms, as discussed. So you want to isolate the radical first. Now that we've isolated the radical, the square and square root do reduce nicely. Now x plus 1 squared, well, we have to write it twice, FOIL it out, x squared plus 2x plus 1, x and x, 2x. This is now a quadratic equation. So I'm going to move all of the stuff on the left to the right by performing its opposite. We now have 0 equaling x squared minus 6x plus 5. This does factor, but we could use the quadratic formula or completing the square as an alternative step or method. X minus 5, x minus 1. Negative 5x and minus 1x is negative 6x, and the last product is positive 5. So we get x equaling 1 and 5. These might be the answers. However, since our original equation had terms that have domain issues, square roots for example, we want to make sure that these answers work. So for x equaling 1, we have the square root of 8 minus 4 minus 1 equaling 1. So I've plugged in the 1 in for this x, 8 times 1 is 8, and this x equals 1. This is the square root of 4 minus 1 equals 1. That's 2 minus 1, that equals 1. Check. So the x equals 1 is valid. And for x equaling 5, we would get the square root of 8 times 5, 40, minus 4 is 36, minus 1. Let's see, that's square root of 36 is 6 minus 1. That should equal 5, and we plug in the 5 on the right, and that also equals 5. Both of these solutions are correct. For those of you that have an answer button on their calculator, like here, ANS, you can check your work. So I would change this equation by moving everything to the left. So I can get it equals 0. So this would be not part of my work, as you can tell, but part of the check. So again, if you have an answer button, put the number in, hit enter, it's now in the temporary answer button location. Then code the equation, square root. Wherever you see the x, you instead use the answer button. 8x turns into 8 answer. Everything else will be the same. So there's the parenthesis, there's the square root, then minus 1, and then minus x, but that's answer button. If 1 is a solution, this should equal 0. Yes, 1 was right. And 5, let me put that in the answer button, pull back up the previous expression, the check expression, and some of your calculators, the up arrow will do that. And this should also equal 0. It's a very nice technique to basically let your calculator work through all the details. And you only have to do it once if you code it in like shown.